So here you are, one of the first Martian colonists preparing to make your arrival on the Red Planet. And if certain prominent people who are popular in the scientific community, or at least popular amongst people who like to watch space-related documentaries and things like that, are correct about this colony, you are about to walk into the worst hellhole imaginable. Far worse than Antarctica, far worse than trying to live at the top of Mount Everest. This is the worst possible place that anybody could possibly try to live, and so your life is going to be absolutely miserable. And for this reason, you wouldn't be here in the first place. You might be here for a short-term exploration mission, but living on Mars? Are you out of your damn mind? There's no way. And even though I've got Bill Nye listed in the title because his name is shorter, Neil deGrasse Tyson is probably the biggest, most annoying advocate for staying the hell off of Mars. He does believe that we should explore it, perhaps have a temporary outpost, that sort of thing, but going there to stay, no damn way, because obviously Mars is a place that we can't breathe. Mars is a place that's entirely too cold, but the thing rather that he likes to talk about the most is the fact that Mars is bombarded by deadly radiation and cosmic rays, and these things make Mars completely uninhabitable without an extensive amount of infrastructure, which would be impossible to construct. End of story. That's pretty much all he has to say about it, and he knows what he's talking about, right? He's Neil deGrasse Tyson. I mean, this is the guy who popularized the notion that Pluto isn't a viable planet anymore, that it never was a planet, and after all, that's what everybody believes now. Of course, there was the Astronomical Union who voted on the whole thing, but he's the guy who made everybody else aware of it, the guy who supports the entire notion, even though I think if Pluto were to be put on a list of viable planets today and voted on, given how dynamic that planet is, especially its geology, there might be a lot more hesitation to remove it from the list of planets now that we know more about it. But that's a different topic. We can trust Neil deGrasse Tyson on this issue, can't we? And Bill Nye believes very much the same thing, along with lots of other people. There are too many problems with colonizing Mars, and we're never gonna do it. Well, that's a load of bull. And I'm going to share 7 of the most popular misconceptions about Martian colonization right now. So here's the first danger on Mars that isn't commonly talked about, but I'm bringing it up first because it is largely true. The entire surface of Mars, as near as we can tell, is covered in perchlorates, chlorine, and 4 atoms of oxygen, if you're interested in what that molecule actually is, and it's pretty damn dangerous, at least on its surface. But the problem I have is that very few people are actually looking at the advantages that all of these perchlorates could actually represent for colonization as opposed to the hazards. And I'm going to be quoting a lot from a paper from Cambridge University called Perchlorate on Mars, a Chemical Hazard and a Resource for Humans. And by the way, it's linked in the description. Now, the main concern about perchlorates is the idea that astronauts are going to bring this dust in on their spacesuits and people are going to breathe it in. If that that actually happened, if Martian colonists were stupid enough to set up their habitat to where that could happen on a large scale, it would be a big concern. Quote, perchlorate is a health concern because it can impair proper functioning of the thyroid gland. Thyroid hormones are responsible for regulating mammalian metabolism, a long-term reduction in iodide uptake in an adult that can ultimately result in thyroid hyperplasia, decreased metabolic rates, and slowing of the function of many organ systems. The presence of ClO4 in the environment and its possible widespread distribution on the Martian surface make it a global hazard to humans on the planet. The main routes of exposure of astronauts to ClO4 on Mars would be through direct inhalation of dust into the respiratory system, ingestion of contaminated water, and ingestion of foods grown in the presence of ClO4. So you can't even really grow anything in this regolith. So that's some pretty negative stuff. Now, of course, there's a number of ways that you could filter the perchlorates out of the regolith, but it would be labor intensive and energy intensive. So this would seem to be a very strong argument for detractors of Martian colonization. Why the hell do you want to set up a colony on a poisonous planet? Well, here's one of the reasons. Solid rocket fuel is often comprised of ammonium perchlorate, NH4ClO4. So half of this formula is made up of perchlorate, so you could use it as solid rocket fuel for the benefit of Martian colonists. But here's a much bigger advantage. Do you notice that there's 4 oxygen atoms in the perchlorate molecule? Is there a way that we could make use of this oxygen for breathing? Well, yes, there is. First of all, a human requires 550 liters worth of oxygen per day. Based on the amount of perchlorates that have been measured in Martian regolith, a daily supply of oxygen for one astronaut could be obtained by a complete disassociation of perchlorates contained in 60 kilograms of regolith. So 60 kilograms of regolith contains enough oxygen for a human for an entire day. But how the hell do you get the oxygen out of the perchlorates? Well, there's actually a very easy way. According to the paper, there are no less than 50 different types of bacteria here on Earth that are capable of breaking down perchlorates and producing oxygen as a byproduct, and you wouldn't even need to take the microbes themselves if you're concerned about contaminating the surface of Mars. Instead, you could simply bring the enzymes that these bacteria create. A mere 100 grams of purified enzyme could generate a daily supply of oxygen for one astronaut in 1 hour. Yeah, believe it or not, the enzymes on humble little bacteria on our own planet are capable of doing that. And what I find to be very interesting, something that I mentioned in a bulletin that I released yesterday, is the fact that there is an unusual and unexpected amount of oxygen in the Martian atmosphere that we cannot explain. But if there's something alive there consuming the perchlorates, which makes a great deal of sense, that's a perfect explanation as to why these strange spikes in oxygen are observed. And the news gets even better. Quote, as a proof of concept, we have developed a portable emergency oxygen system that can provide an astronaut with 1 hour of breathable oxygen based on soil perchlorate decomposition catalyzed by enzymes extracted from perchlorate-reducing bacteria. The astronaut could collect 6 kilograms worth of Martian regolith into a bag and add water, which would dissolve and carry the highly soluble ClO4 into a container holding the enzymes. The oxygen produced could be directly fed into the astronaut's suit. There are many useful applications for this poison in the Martian regolith, and as a matter of fact, it may be the source of sustenance for Martian life already. Now, related to this misconception is the idea if there is any life on Mars, we're going to contaminate it with our own earthbound bacteria and destroy it, thus therefore creating initiating sort of a genocide of the first alien life that we find. And this also is not well supported by the science because of those same perchlorates. Perchlorates, especially exposed to UV radiation, tend to be extremely hostile to the vast majority of bacteria on Earth, aside from those that thrive off of perchlorates. That being the case, almost all of the hostile bacteria that we may introduce to the red planet are going to be wiped out by the hostile conditions. I'd have to say that any bacteria that's been able to survive all these millions of years of perchlorates and cosmic rays are going to be more than capable of handling what limited amount of bacteria we can throw at it. If anything, I think that Martian life represents a greater threat to us than the other way around. Something else that I pointed out in that bulletin that I released yesterday that very few people seem to be watching right now. I think that's more because YouTube wants to shut down anything that's controversial than you guys making a conscious decision to not watch it. But let's move on to radiation. Yes, radiation is going to be the biggest threat to Martian colonists. It's going to give everybody cancer and they're all going to be dead in a decade or so, right? Right, wrong, not even close. Have a look at this map of the radiation levels on the surface of Mars that have been observed by the Curiosity rover and other rovers on the surface of the planet together with orbital observations. It would appear that as thin as the Martian atmosphere is, it still provides a tremendous amount of protection to the Martian surface. As you can see, there are some regions of the planet that have half the radiation exposure that the rest of the regions do. But what does all of this mean? Well, a full sievert worth of radiation represents an increased chance of cancer in about 20% of the people who are exposed to it many decades in the future. So, assuming you actually accumulate a full sievert worth of radiation on the Martian surface, which would mean you'd have to sit around outside unprotected during the entire time, it would take a minimum of 10 years worth of unprotected exposure, at least in the low radiation areas like the bottom of the Valles Marineris, where we are considering setting up a colony in order to accumulate that 1 sievert worth of radiation, which gives you a 20% chance of developing some kind of fatal cancer much later on in your life. That is, of course, assuming that we aren't constantly testing Martian colonists for cancer on an annual basis, which of course we would be doing, and early detection is the key to going into remission, which means even those 20% would probably have a decent chance of survival with today's medical technology. So it's not as big of a threat as we're thinking. Now let's take it a step further. Let's say that you only spend 6 hours out of every 24 out on EVAs every single day. That's actually a hell of a long time to be spending outside while you're on Mars, but let's just assume that you're an outdoors type of person and you want to go out on EVAs that often. That being the case, it would take 40 years to accumulate that 1 sievert worth of radiation. Virtually no threat to somebody who's early middle-aged who makes the decision to colonize Mars. Now, of course, pregnant women, children, chances are they're going to have to stay in an enclosed and shielded area for a much longer period of time than the average individual in order to keep them safe. But as far as an adult is concerned, this is not nearly as big of a threat as everybody seems to think it is. Now, interplanetary cosmic rays and radiation, that's a different story. If you don't have sufficient protection, you could theoretically suck up half of that 1 sievert worth of radiation in the 6 months that it takes you to get from Earth to Mars, assuming that some sort of major solar event or at least a high degree of solar activity was taking place. That could actually get you sick in such a short amount of time. However, However, if you have up to 20 grams worth of mass protecting you, and this is just aluminum, by the way, per square centimeter, that's enough to reduce this dose down to about 1/10 of 1 sievert in an entire year, and half of that for only 6 months. So protection is going to mean a lot. 20 grams per square centimeter is also a lot of mass. We're talking about 12 tons for the entire surface area of Starship's fairing. However, keep in mind, 40% of that 12 tons would actually be made up of the type of stainless steel that Elon intends to use for Starship. So really, you would only need maybe 7 or 8 tons worth of extra mass, and that could be made up of water circulating through the exterior skin of Starship, water that you would probably need anyway. So when Elon has said that he's not terribly concerned about interplanetary radiation, he actually kinda knows what he's talking about, which isn't surprising given that the guy's a physicist. Now, connected to the whole radiation myth is the notion that we're all going to have to live underground because of the problems represented by radiation. But actually, shielding ourselves from radiation is a pretty straightforward affair on Mars, utilizing in situ materials, such as basaltic fiber and also in situ manufactured HDPE, such as represented in this particular design that was part of a competition that NASA did a few years ago, utilizing in situ resources and 3D printing to construct habitats via automated methods before astronauts even arrive on Mars. NASA is definitely looking at the possibilities of long-term stays on Mars, indicating that they're actually kind of behind this notion, really. What you're looking at right now is the nature of solar radiation on Mars. The Curiosity rover discovered that solar radiation coming in from about a 30-degree angle down to the horizon is not terribly dangerous, simply because there's a lot of atmosphere in between the sun and the astronaut on the surface. Moreover, Curiosity also discovered that once it was at the base of a cliff, radiation levels dropped off tremendously. So as a result, these designs have windows with overhangs that create sort of an artificial cliff, reducing any radiation that might pierce into the structure, that is to say, those that could come in through the windows, as opposed to the basaltic fiber walls, which would be virtually impervious to radiation. Now, virtually all of the designs in the competition had some sort of automated, reusable construction ship that would set down on the Martian surface first, and it would make use of these in situ materials, primarily basaltic regolith, in order to manufacture these types of structures. And by the way, basaltic fiber is very strong material and also highly radiation resistant. And on top of that, most of these concepts had a great deal of modular design and redundancy built into the structure. That is to say that each individual module had its own life support systems, could be isolated from the rest of the structure in the event of some sort of breach, and on top of that, you also have a tremendous amount of redundancy built into food production, into living space, and virtually everything else. Plus, as I said, these construction ships are reusable. Therefore, they can be used to create one module after another without ever running out of material, because virtually everything they use is in situ resources. And also, the ships, the construction ships, can be used as emergency habitats in the event of some sort of extreme event. So there is very little reason to believe that we absolutely have to bury ourselves deep underground and never get to see this amazing planet that we're settling on. On the contrary, there are many innovative ways to create these sorts of habitats on the surface, remain completely protected from radiation, and have a glorious view of the Martian landscape. And by the way, as you can see, this particular design has this enormous window that lets in a considerable considerable amount of natural light and gives you a tremendous view of the Martian landscape. And it also has a translucent radiation shield that closes over it when the sun is directly opposite the window in order to provide radiation protection. This actually, to me, is a pretty pleasant looking place to live, and it's on the surface, and we, as surface-dwelling diurnal creatures, I think are going to need these sorts of habitats in order to be happy and psychologically stable. And related to this is another misconception that life will be work, survival, and nothing else. First of all, as you can see, we can build habitats on Mars that are pretty pleasant to live in. But on top of that, there are all kinds of activities that you can perform on Mars that you really can't do on Earth. For example, 1/3 G basketball. Can you imagine what that would be like? And also, there is the notion of dry ice skiing or dry ice snowboarding. I've talked about that a couple of times in the past. Since dry ice is often frozen on Mars, you can create sort of a cushion of air or a cushion of gas underneath the dry ice that allows it to practically slide down sand, as you can see here, even on a comparatively gentle slope. It just keeps going and going and going. What an amazing experience that would be to coat the bottom of a snowboard with dry ice and take off down a Martian sand dune. Now, granted, this would be pretty dangerous in an EVA suit. However, I've done some videos about reverse mechanically engineered suits that are different, and if they experience some sort of tear or breach, they're actually pretty easy to patch. You could still shatter your faceplate, of course, which would be the end of your life, but any extreme sport involves tremendous risk, even here on this planet. And imagine zooming down Martian dunes with something like this and performing unbelievable tricks in 1/3 G. That would be an extreme sport that would attract viewers around the solar system. And this provides a nice segue into subject number 6. Living on Mars will be far worse than living in Antarctica, or perhaps at the top of Mount Everest or something like that. First of all, both Antarctica and Mount Everest have tremendous winds that would utterly destroy any habitats that you decided to set up there. Also, Mount Everest experiences colossal and deadly avalanches virtually any place you go there, something that you wouldn't necessarily encounter on Mars, depending on where you go. On top of that, many of the settlements that we have established in Antarctica are not in very interesting places. And if we set up a colony on Mars, it's all going to be about location, location, location. We haven't sent any rovers to the most interesting places on Mars. Can you imagine a habitat set up, say, at the base of Olympus Mons? Just the plateau that Olympus Mons sits on is as high as Mount Everest, cliffs the height of Everest at the base of Olympus Mons. And then, of course, there's also the largest canyon in the solar system with cliff walls 8 kilometers high. We've never sent anything there as well, but we really should consider establishing a colony there. We should establish a colony in a place where Mars really does look alien, where we experience visuals that we simply couldn't experience anywhere on Earth. This is what would make living on Mars a unique experience. Would it be fun? Probably not. It would be a lot of hard work and a lot of survival, but it would also be incredibly exciting. The same sort of excitement experienced by 19th century explorers who went into the depths of Africa, many of whom died under very unpleasant circumstances, and yet still wouldn't have had it any other way. And then finally, for those cynics who believe that we can colonize Mars, but we shouldn't and should stay focused on Earth, they believe that only the rich and privileged are going to take advantage of this escape valve once Earth goes to hell. And that is simply a load of bullshit. And the reasons for this should be abundantly obvious. A Martian colony is going to be a place inhabited by idealists. If people want to escape the hellhole on Earth and go to a pleasant place, they're going to be going to an orbiting facility that has artificial gravity and all sorts of comforts like Jeff Bezos imagines all the time. Those who go to Mars truly want to make us into a multiplanetary civilization that can survive in the long run, not people who are looking simply to escape in the short run. And those who do go to Mars are going to have to serve very specific purposes. We're not only going to need biologists and geologists and engineers, we're also going to need cooks and service people and administrators and accountants. Everything required for a functioning society. Everybody is going to have to play an important and critical role in this society if it's going to function and it's going to succeed. And that sure as hell isn't going to happen if only the rich and privileged get to go here. Isn't gonna happen, guys. Mars is a place for idealists, not for the pampered and the uber rich, except maybe for Elon Musk, assuming he really wants to go there. So what really are the problems with Mars? Well, there are actually many. I believe that Martian dust storms may represent a much more serious threat than anybody thinks, given their electrostatic nature and the fact that they may be disruptive to our electronic technology. And they also might adhere to faceplates during a dust storm, making vision impossible, for example. On top of that, we've started to detect stronger Mars quakes than we ever thought were possible. Just a couple days ago, we detected one that rated 5 on the Richter scale. Now, this is a pretty modest quake by Earth standards, but it might be enough to shake loose debris at the top of a very high cliff, and landslides in the Valles Marineris, for example, can be utterly devastating. A cascading wall of debris coming down from 8 kilometers high, accelerating to almost 2/3 the speed of sound. Yes, that's how devastating these landslides have been in the past, and now that we know that Mars is geologically active, setting up a colony in a low-lying area in order to provide protection from radiation could be problematic for reasons that we haven't discovered yet. I think it's the things we haven't found on Mars that could represent a problem. But I hope I've proved to most of you that the problems we think make Martian colonization impossible or impractical really are exaggerated or can be overcome with innovative solutions. And until everybody realizes that, we're not going to be colonizing Mars, so hopefully we're going to be having some sort of paradigm shift soon. If you like this content, please subscribe to my channel, and also check out the description. I could really use some support as well. Colonizing Mars is unquestionably going to be the greatest adventure that mankind has embarked on since we first crawled out of the primordial ooze. But what do we do after we go to Mars? What happens if we do set up a self-sustaining colony there? How does it become self-sustaining, and why do we want to go even further than that? Well, that's going to be the topic of my next episode of this 3-part series. So until we are ready to embark on this amazing adventure as a species and as a society, I urge all of you to stay angry about space.